Hello, everyone, and welcome to the Fall 2021 CSAFE webinar series sponsored by NIST as we present Bloodstain Pattern Analysis Black Box Study. Your speakers today are Austin Hicklin, Paul Kish, and Kevin Weiner. Paul and Kevin are both on an advisory board for CSAFE. We call it RTAB. Kevin comes to us as the director of the Kansas City, Missouri Police Department Crime Lab. Paul Kish is a forensic consultant with Paul Irwin Kish, Forensic Consultant and Associates. And Austin Hicklin is the director of the Noblis Forensic Science Group. Gentlemen, the webinar is yours.
Okay, I'm Austin Hicklin with Noblis. Kevin Weiner and Paul Kish are also here. I drew the short straw, so I'll be doing most of the presentation, and Kevin and Paul will be available for questions. We've got a lot of information available, so if you send in questions, we won't get to them until the end. Okay, I would also like to make sure we mention our co-authors across the bottom in this study. So let me start with disclaimers. This is an NIJ project. The grant number is up at the top of the screen. The opinions, findings, and recommendations are ours. They do not necessarily reflect DOJ. So significance, I think we're well past 100 people so far. And so there's a variety of background in forensics and blood pattern. Sometimes BPA, bloodstain pattern analysis, is critical evidence. And so one example is a David Cam case in which the BPA analysts for the prosecution concluded the bloodstain pattern on the defendant's clothing was backspatter from a gunshot, but the BPA analyst for the defense concluded it was a transfer stain resulting from the defendant assisting his wounded children. Very serious. And so reproducibility was a critical aspect of the case. There are fundamentally contradictory opinions among BPA analysts regarding the classification of the bloodstain pattern that was the key evidence in the case. So about 10 years ago, the National Academy's National Research Council came out with a report, and it was fairly critical of BPA. Some of the quotes: scientific studies support some aspects of bloodstain pattern analysis. One can tell, for example, if the blood spattered quickly or slowly, but some experts extrapolate far beyond what can be supported. The uncertainties associated with bloodstain pattern analysis are enormous, and in general, the opinions of BPA analysts are more subjective than scientific. These are the reasons why we did the study, to try to have a large-scale test of the accuracy and reproducibility of bloodstain pattern conclusions. So as an overview, the purpose is to rigorously measure the accuracy and reproducibility of conclusions by practicing BPA analysts. The participants were asked to examine 150 bloodstain patterns over a period of 18 weeks. The study was open to practicing BPA analysts to handle people who were recently retired. We limited it to people who had conducted operational casework within the previous 2 years. The study was conducted using custom web-based software. All the results are anonymous, and as part of the human subjects research, we guaranteed that results won't be aggregated in a way that compromises anonymity. The results were, however, coded so that the participants who chose to see their anonymized results could look up an anonymous code in the appendix to the study if they chose to do so. We do not know who retained their code or who, and we do not know who looked up their results. It was published recently in Forensic Science International. The reference is here. There's a link at the end that will have it. So the report, extensive appendices, and the data are open access and free to download. So the bloodstain patterns and information provided. The samples were acquired both through controlled collection in a laboratory and operational casework. The study included a total of 192 bloodstain samples. Each participant was assigned 150 of these. Most of the time, a bloodstain sample had multiple images presented, so they had up to 9 images for every sample. We had very limited metadata so that we did not bias the participants, that the information about the samples and images was limited to the type of surface and whether it was horizontal or vertical. The study website presented medium resolution images in the browser and allowed downloading of the full resolution images. So responses. One complicated thing, we've run a variety of black box studies. I don't know if you know the background, but I've run a variety of tests on latent fingerprint examination. We've done handwriting, we've done bullets, we've done footwear. Unlike all of those, there is not a pre-existing conclusion standard we could just adopt. And so therefore we had to develop methods to collect participants' assessments. So one approach is summary conclusions, which we nicknamed tweets, short text descriptions. Another was classifications using terminology explicitly from the OSAC ASB standard. This is several years ago. OSAC developed a terminology specification that has been officially recognized by the AAFS standard board as a standard. And all terminology we used was explicitly pointing to that. And also open-ended questions. So this provided 3 different tools to collect information about every sample and about every participant. So every participant who completed the study received a mix of the 3 types, that everybody got 150 samples, 30 of which they were asked to give summary conclusions, and 120 were classifications and or questions. Again, the terms were explicitly from the OSAC ASB terminology specification. So the rationale on assessing short text and the reason we have the questions, that short text is notoriously difficult to assess and compare fairly. And so our approach was the summary conclusions were front-loaded, and then as people made statements in the summary conclusions, we turned those into questions so that we could assess the reproducibility of statements made in the short text. And so the questions evolved over the course of the study so that basically the people who made summary conclusions at the beginning, we could assess the reproducibility of those. So for example, here is a controlled collection bloodstain. And this is an example of what we provided as one of the images. So the instructions: for every sample provided, write 2 concise statements, each less than about 75 words, summarizing your expert opinion. 1, observations, and 2, mechanisms responsible for the bloodstains. So for example, here are ones that we received in the test for this bloodstain. And so observation describes an irregularly shaped stain with measurements, fairly defined edges, and 6 smaller circular reddish brown stains within the overall stain. Can people see my mouse if I move it?
Yes.
Oh, okay. And so there, and then that person said, as an example, as the mechanism, this is consistent with a possible transfer stain or possible saturation stain. The lower one talks about an irregular shaped blood stain and size, characteristic of a saturation stain. Again, mentions the 6 small blood stains exhibit characteristics of a drip trail. And so here they talk about source of liquid blood on the carpet, and a source was moving above the carpet for a short distance. Okay, so that was the first way we collected information. Other people were asked classifications and questions. And so for the classifications, we would ask them to use this 3-level response scale. The 3-level response scale took a lot of evolutions over the course of alpha and beta testing, that we started with the assumption we'd go with a 5-level Likert scale, and that was really problematic for a variety of reasons. So the scale we ended up with was that for any given classification, respond that it was definitive, as in correct and accurate, and you are certain the mechanism was involved. Excluded, the classification cannot be responsible and you're certain it could not have been involved, and included is anything in between. And so all the classifications we provided were terms from the OSAC standard, and the study website showed the definition for every term. So all they'd have to do was hover over a term and it showed the definition. So they couldn't be separated from that definition. Each sample had a various numbers of classification prompts, up to 6, but on average it was about 4. And so, for example, with this one, it was provided with 3 different classifications. The correct classification was not always present. Sometimes classifications overlapped so that more than one was present. Questions. The third type of responses. And so for each pattern, you'll be asked to respond to a series of questions and consider each question as if you're being asked it as an expert witness in court. On average, there are 1 or 2 questions for each sample, and it was up to 5. And again, generally the questions were in response to statements people made in the short text earlier in the study. The responses with these were yes, no, and possible. Yes, you agree with it entirely. No, you disagree with it as stated. And possible, if not certain, partly true, partly false, or anything else. And so, for example, questions, and I believe all of these were from statements made in short text responses. And you could see this was the first one was from one of the examples I had. Was a source of liquid blood moving over the carpet for a short distance? Are cast-off stains present? Was this caused by a transfer mechanism? Do the 6 blood stains correspond to a drip trail? So now you see what mechanism we had of getting the responses from the participants. So let me do a summary of the data. We had 192 bloodstain samples. 123 were from controlled collection in the lab. Generally, we videotaped these. Almost always we videotaped them. There were 69 from operational casework. The reason that we have operational casework is interesting. I found in doing studies that one of the things is if you have everything with controlled collection and the participants know that, that limits how they respond. If they have things, however, from operational casework, they cannot necessarily assume that everything is something that we would have done in a lab, that we were certainly not shooting people in the lab. With this, however, we have no limitations on that. And so the reason we have operational casework is that. I'll be talking more about what that means in just a second. We had 75 participants. There were 45 of whom completed all of the assigned samples. Out of the 192 bloodstain samples, we had 815 classification prompts. That's over 27,000 responses we received. That on every classification prompt, we had an average of 33 participants per. On the questions, there are 223 questions, far fewer questions, and nearly 6,000 responses, a mean of about 27 participants per question. Short text, 1,700 responses, and this means an average of 9 responses per sample. So that's the data. One thing I want to talk about is known cause, because we do have casework and controlled collection. So we are using the term known cause to refer to definitive ground truth knowledge of the cause of each bloodstain or for specific classification or question. So we videotaped virtually all the controlled collection samples, and so we have ground truth attribution of the events that created the bloodstains, and the casework, we generally can't claim definitive knowledge of the cause. The reason this gets complicated is if it's at all debatable or semantic, we left cause as undefined. And so generally, controlled collection samples, we define known cause, but we didn't always. One unexpected finding, in some instances due to semantic issues, we can't always define known cause for a specific classification or question, even when we have video. We have terms such as pool or saturation stain. If it's a single drop, can it be a saturation stain? There are a lot of cases where the terminology didn't define its boundaries well enough. And I'm working with two of the experts in the discipline here, that when we had something where with semantic issues, we could look at a video, we knew exactly how we created it, we still sometimes couldn't define whether a specific classification was arguable or true or false. And so we usually define known cause for controlled collection, but not always. Conversely, casework samples, we almost always did not define known cause. We did, however, have some casework samples where the specific casework information was known definitively. And in particular, if we knew something was impossible, then we could define a cause as false. So what this means, we can assess accuracy and error, if the people are right or wrong, only when we assessed known cause. However, we can assess reproducibility and consensus on everything. That's the way we're proceeding. So let's start with accuracy and error. We'll be having a fair number of charts like this. So let me pause and go through this. This is an area chart. This shows 27,000 responses on the 815 classification prompts. And on average, there's 33 participants per prompt. So across the bottom, we see they're split into columns by known cause. And so the left column, these are the classification prompts that we defined cause as true. So there are 157 prompts and there are 4,600 responses to those. To the right, the ones we knew were defined as false were 235 prompts and nearly 7,000 responses, and unknown in the middle. And so remember, in general, we defined known cause for the ones that were controlled collection. In general, we left it as unknown for the casework. And so what we're particularly interested in here, you can see the proportion of each response. Green means definitive, gray is included, which is basically indeterminate, and orange is excluded. So for classifications that were true, where the classifications that were known to be the cause of the sample, 52.8% of the responses were definitive. These can be described as true positives. At the other corner, when classifications were known not to be the cause of a sample, 60% of the responses were excluded. These are true negatives. So if we go to the other side, then we get to things that are contrary to known cause. For classifications that are known to be the cause, 15% of the responses were excluded, false negatives. These are contrary to known cause, and so these are errors. And up in the top corner, for classifications that were known not to be the cause, 8.5% of the responses were definitive, false positives. So this is across all of the classifications. One of the things, however, is that some classifications are relatively minor or trivial, and some classifications could be considered to be fairly important. And so we had a step where Paul and Kevin walked through all of these and assessed for each of them whether either an error on a classification or a disagreement between exam analysts on a classification would be likely to be consequential, significant, if it happened in court. And so we assessed a subset of the classification prompts as to whether they were most consequential. And so if we limit it to most consequential, then we get this chart. Let me bounce to the previous chart and this one. So the open issue was, is there something where there's a profoundly different distribution if you have it limited to the most important classifications and get rid of the trivia? And in short, no. The false positives are overall, they're 8.5%. Here it's 8.2%. The false negatives were 15% for all classifications, and here it drops to 9.8%. But the overall distributions are not that different. For questions, we see a similar response, distribution of responses. Here, green is yes, orange is no, and gray is indeterminate possible. But otherwise, they are assessed in a similar way. We had a greater proportion of unknown. A lot of the questions got complicated enough. We were tentative on claiming known cause. But similar overall kind of pattern. When questions are known to be true, 46.7% were yes. When they were known to be false, 39.2% were no. Those are true negatives. False negatives were 8.4%. False positives were 12.2%. If we take this and limit it to the questions that we're seen as most consequential, we have a similar pattern that the false positives, they drop, that false positives were 12.2 for all the questions, 7.9 for the most consequential. False negatives were 8.4, but dropped to 3.3 for the most consequential. The overall pattern is similar. It's the rate of errors does drop when you go to the most consequential. But as an overall summary, overall, when the cause of a bloodstain was known, 11.2% of the responses were erroneous. If you drop it down to the ones that were flagged as most consequential, that's 8.7% were erroneous. Short text responses. So short text, we had 1,700 total short text responses. Just over 1,000 of these were on samples with known cause. Of the short text responses, 5% of them completely contradicted known cause, 11% partially contradicted. They had some part of it was contradictory, was an error, and part of it was not. So correct and incorrect statements. There were 70% everything they said was correct, and 11% were just indeterminate. A different way of assessing the short text responses was on review. And so on review by the BPA analysts on the team, we reviewed all of the short text responses, we meaning Paul and Kevin, and looked for errors in reconstruction statements, observations, or unsupported conclusions. And so this is more of a subjective assessment, but we wanted to make sure we had an assessment of the responses, even the ones where we didn't have ground truth. 11.3% were they assessed as having errors in the reconstruction statements, observations, or unsupported conclusions. Next, let's talk about consensus. Entirely different type of chart. Here, let's start with just the classifications that we assessed as true. And so this is showing 157 dots here, and there's an average of 33 participants per prompt. And the large circles are the ones that were assessed as most consequential. Small circles are not. For each of these, basically we have 33 votes on every one of these on whether the response should be definitive. And if everybody said definitive, it's going to be in the bottom right corner at 100%. Or if it should be excluded, in which case it would be the top left corner at 100%. And so there is pile up here, but most of the things were not unanimous. It's one of these where you would kind of expect that definitive would have a pile up in the bottom right corner, given that these are the ones where known cause was true. So for example, just pulling one out, this is something where altered on a particular sample, we knew to be true. There were 19 responses. 10 of those were definitive, so it's over 50% left to right. 3 were included and 6 were excluded. And so that means that it's just almost a third of the way up from bottom to top. And so that way, everything in here you can see as basically, on average, there are 33 votes in a decision space of where things should fit. So, for example, out of the true classifications, out of the 157, most of them had a majority of definitive responses. And this is something or other where I use the word correct cautiously. We can say incorrect more clearly, because if something contradicts ground truth, I'm cautious on using the word correct because indeterminate is not incorrect. And so but here, this is something where definitive responses are consistent with ground truth, and 58% of the true classifications, the majority of the responses were definitive. These are ones where a majority of the responses were in error, there were 8 out of these where a majority of the responses were excluded, which we know to be false. There were 4 where 75% of the responses, so a supermajority, were in error. So this was in ones we knew to be true. Same thing, here we're showing the ones that were known to be false. So 235 dots. Again, the large circles are the most consequential. And you can see cluster towards the top, there is a pile up at 100%, but there's a scattering all the way across. Now note that anything that is not on the leftmost axis has some errors. That percent definitive in this case, it means that anything that is not at 0% on the x-axis has errors involved. So here, there's only one of the ones that were known to be false that had a majority of responses were definitive. And about 2/3 of the classifications had a majority of the responses were excluded. If you take all of the classifications, and the gray is unknown, red is false, blue is true, now we see this overall scatter. And so we see a range that if everybody agreed on everything, then we'd see a pile up at 100% in the corners. And if everybody agreed it would be unknown, it would be a pile up at 0 in the bottom left corner. We see a lot of range of opinions on what the correct responses should be. So 3% of the responses were unanimous. 1/3 of the responses had at least 75% consensus, and 81% had a majority consensus. So the majority was generally correct. The majority was incorrect on 2.3% of the classification prompts, 1% of the questions. The majority was never incorrect on something that we flagged as most consequential. Reproducibility is a similar concept to consensus. With this, though, it's pairwise comparison. For any response made by a participant, what are the odds that what proportion of other participants agreed or contradicted that conclusion? And so 54%, if you have all pairwise combinations of participants on prompts, 54% of responses were the same. 7.8% of responses were contradictory. So for example, for every participant who responded excluded on a classification prompt, 65% of the other participants also responded excluded. They're agreeing. 25.3% responded included, and 9.4% responded definitive, contradiction. And so reproducibility we can assess on casework, or things where we don't have known cause, that we don't, if somebody says excluded and somebody says definitive, we don't have to know who is right to recognize there's a contradiction. And so reproducibility is something that can be more broadly measured than just accuracy. If we limit to the most consequential prompts, the numbers didn't change that much. Instead of the 54.6 at the top, it's 56.3. Instead of 7.8, it's 6.2%. Comparing analysts. We had 75 participants. On this chart, we're talking about 56 participants who had at least 50 samples each. That participants who had relatively few samples, the rates are not statistically strong enough for us to be able to compare. And so for the 56 participants with at least 50 samples each, we put them on a scale of, on the x-axis, what portion of their responses were indeterminate. And so if they're more decisive, they're over at the left. If they have more possible or inconclusive responses, they're going to be over to the right. The y-axis is talking about contradicting known cause. And so if it's something or other where they have a lot of statements that are contradicting no cause when it is known, they're going to be higher on this chart. And if that happens rarely, then it'll happen, then they'll be lower on this chart. Now, one interesting thing is that if somebody is indeterminate, if they say possible or inconclusive, then they're going to be way over on the right, but they never contradict known cause. And so they can be on the bottom axis, 0% on the y-axis, if somebody always gives an indeterminate response. They're never wrong, but they do that because they're making very few conclusive judgments. We see an overall spread here that it's something where you can look in the paper, and my general response to most everything I'm going to get is look in the paper, it's described in detail. We did ROC analysis on the effectiveness of the participants. And basically the least effective quartile are shown in blue. This means how effectiveness, meaning what is their proportion of correct but determinate conclusions. And so the ones who had the most correct conclusions that were not indeterminate are going to be blue, and the ones with the fewest are going to be in black. There is a big spread. There is a diagonal here. And so, because some of this is, you want to be towards the bottom left. You don't want to contradict known cause. That's really important. And so you don't want to be high on this chart. But to be effective, you have to have at least some responses where they're conclusive. And so you want to be generally over to the left. The means are shown in dotted lines. And so you can see generally there's a diagonal that if people have more indeterminate responses, then generally they're going to be looking better on the y-axis. If they look better on the x-axis, they generally look better on the worse on the y-axis, and vice versa. Let me point out there are two anomalous participants that jump out. The top left, there was one participant who contradicted known cause on 32% of their prompts, 36% on the highly consequential, and it was only indeterminate 4% of the time. That person was responsible for 5.7% of all the errors in the study. The bottom right is someone who contradicted known cause on 4% of the prompts. And only contradicted known cause on 1% of the highly consequential prompts. But the way that happened was that person was indeterminate 80% of the time. So we have two extremes. The top left was always sure, or is almost always sure, but often wrong. The one at the bottom right was almost never wrong, but almost never sure. Associations between examiner background and performance. So we assessed 25 background attributes for associations with performance. We had a detailed questionnaire that every participant completed. We did not detect support for any notable associations between participants' background and performance. This is something where a huge amount of work and statistical analysis goes into this statement. Most background attributes had no associations with performance, including length of training, educational degree, certification, length of experience. Let me point in something, because I can anticipate one question that you would expect that more experience and would have an improved result in almost anything. But we are not testing novices against experienced people. We are testing people who are all practicing. And so in most of the studies we've done, we don't have people who are in training, novices, just barely out of training, and comparing them. We're talking about people who have a lot of experience with people who have moderate experience with people who have a great deal of experience. With that, we do not see associations of performance. We did find some limited associations. They're very limited and come with a lot of caveats. That's too complex for the presentation. See the publication for those details. So let me provide some examples. One of my favorite examples, Paul is holding the cardboard and Kevin is, well, Kevin, Kevin drew his own blood and had a test tube in his mouth and expirated it there. And so one thing, we have the numbers. I don't know if you saw at the top left, this is some pre-numbered as sample 240, which, well, this is sample 240. And so when this was provided to participants in 3 different images, so they had details in the overall. So, well, we know this is expiration, and you know that too. You saw the video. It's controlled collection. And so one of the prompts we provided for this was impact. 16% said it was definitive that this was impact. That we know it's not. 23 said included, and 4 excluded. So that's out of 43 people overall. Here's another example. This is casework. This is something where, in this case, this is in the basement. There was a murder in the kitchen above. The blood dripped through the ceiling into the basement. And so this is what happened in the crime scene below. So it's a drip pattern. The victim was shot and killed, as I said. So one of the prompts that was provided was impact. And out of 43 people, 15 said definitive, 11 said included, 17 said excluded, and so out of 43 total. So one thing is, whether or not you know the ground truth for a sample, it's pretty close to equal thirds on definitive, included, excluded. And so those contradictions are of interest. So in conclusion, conclusions by BP analysts were often erroneous, that such conclusions could have serious implications if they occurred in casework, as would conflicting conclusions among BPA analysts if they resulted in conflicting testimony in court. Many of the disagreements among BPA analysts and some of the errors may be attributable to semantic differences. There's often a lack of agreement on the meaning and usage of BPA terminology and classifications, suggesting a need for improved standards. That in the appendices to the publication, we go at great length on semantic issues we discussed and recommendations on tightening up some terminology. So the lack of criteria for classification decisions means we can't expect high rates of reproducibility among analysts. Some of this is semantic, but if you have terms where the delineation between 2 different terms is ambiguous and people do not agree on it, that means we can't expect people to reproduce. Report makes a series of specific recommendations about terminology, methodology, and implications for casework. Limitations. So the results here are estimates for use in decision-making, improving procedures and training, and future research. These should not be taken to be precise measures of operational error rates. BPA is not solely defined by pattern classification. It includes multiple other aspects that weren't evaluated in this study. The study differed from operational casework. The analysts were asked to provide responses based solely on photographs. They were not at the scene. They were not provided case-relevant facts that may have aided in making conclusions. And the means of reporting conclusions were different from the manner in which BPA analysts typically reach conclusions. But as I said, there wasn't a predefined conclusion scale that we could use. And these results don't account for operational quality assurance measures such as technical review or verification. So for more information, the easiest way, rather than the link, is just if you email bloodstain@noblis.org, their auto reply will include the link to the publication, the appendices, the tables, all the full resolution images and videos are available also. They are up on OSF, and that link is going to be there as well. Everything's freely available. And if you have technical questions, you can contact me, Kevin, or Paul. And I believe we now can get into questions. So I'm going to stop sharing. Are there patterns in which problems had more responses? They were assigned in order. And so there were people who quit early. They couldn't skip something and go on later. And so it's not something where that's something just from test design. You don't want something where people can pick and choose what they respond to. So I believe that is what the question is about. And so, yeah, 45 of the 75 people completed the entire study. We included people, we did not include, I believe there were 3 individuals who did not have at least 5 responses or responses on 5 samples, I think, and we had 58 people had at least 50 responses, but I think that response answers that one. Were you able to compare the casework examples with the actual responses in the case? We did not compare the responses used in the casework itself with the answers here. That would sort of cross a line on associating this with casework. Could the lack of notable associations have anything to do with the number of participants? The lack of notable associations. I'm having difficulty understanding what that means.
I think what the respondent is saying is talking about associating the participants' training experience, their performance.
So one headache we have with these studies is that we have to deal with volunteers. And so we can't dictate everybody in the field has to take this, and every person in the world who calls himself a BPA analyst would have to take this. And so that means that it is a sample of, well, it's a sample of convenience is what it is statistically what it's called. But with volunteers, that's what we have to do. So the number of participants, that's why we talk a lot about proportions. We can talk about the proportions given these participants. And if we have a broader number of participants, then the answers are going to vary. But we are talking about people who are operational BPA analysts. And so it's, if we see things, if we did the study again with a bigger, broader, different population, I would assume that the individual percentages would certainly change, but I think the general findings would not be, I would be surprised if they would change overall. So let's see. Did I understand correctly? You said indeterminate response is not an error. If you know ground truth and an exclusion is the right answer or eliminates a suspect or a cause, how is that not an error? Kevin or Paul, you want to answer that? I mean, I can, but I've been talking too much.
Certainly, I'll give it a shot. I mean, part of it is if somebody is constantly indeterminate and they're basically possible, then the question or the challenge that we have in this study is if they're saying one thing that's wrong is possible, what we don't know is if they're also saying that thing is right is also impossible or not. So it becomes a complicated situation to address.
Also, sort of in particular, we know how something occurred. That it is a very different question to say if these images contain sufficient evidence to make that determination. And so very frequently that we know how something happened, but whether or not there is enough evidence in the image to make that conclusion is a judgment of expertise. And so I think across the board, it's something where, and this is going to be true in fingerprints as well, if you have really, really, really crappy fingerprints, sorry, technical term, and somebody says inconclusive, even if we know the ground truth, we can't claim that, the inconclusive is an error. The only way we can do that is by judgment with comparison with other people. That if you have a fingerprint that's approaching, let's say it's an approaching completely blank, it's ridiculous to consider that the ground truth answer is the air quote correct answer. And so an indeterminate response, we do not consider as an error. Let me see. Let's see sorry, Paul?
Yeah, so relative to that indeterminate answer, from a practitioner standpoint, based upon the patterns, some of the patterns that were provided in the study, it was kind of interesting how more people did not actually put that down as a response, and quite often were pretty definitive, more so than what I would have anticipated.
And so there's something on the top. If the samples didn't contain sufficient information, wouldn't significant majority find it inconclusive? Significant majority is what I'm pausing on, is that basically, if somebody says inconclusive, that is one person's vote that there is not sufficient information. And so if it's a majority, it means that most of the people don't think it has information. It's something where it's, and so that's why I spent the time on the decision space, where it was the triangle with the dots, that basically you've got a whole bunch of votes on whether they consider there's enough information. And so, if a significant majority finds it inconclusive, then that would indicate there is general consensus that it doesn't have sufficient information.
And to follow on that, there is not a specific method that defines at what point is there sufficient information. So there's nothing that subject matter experts for the study that we can point to and say, well, this, and this were present, so they should have said it must be definitive. There was nothing to point to that. So I think that also speaks to why we thought inconclusive many times was, especially with some of the samples that were provided where there's not a whole lot of information to make the classification, that was probably an appropriate response.
Let me see. It's interesting here. Paul or Kevin, you want to answer the next one, the one that's starting, it's interesting that lengthy experience?
Yeah, I'll give that a shot. So I agree. The question is if somebody has a lot of experience doing the work, but they don't know how accurate they've been throughout their career, that could be problematic. And I think that's what the question is pointing to, is if you're not getting feedback about your accuracy of your results, and if you're doing casework, one could argue that you might not ever get that, or never know ground truth or no known cause. That could be a problem.
Let's see. We answered the top one. The next one is, how does the BPA plots compare with other disciplines we've studied? I'm hesitant to compare this to other disciplines in that, well, one thing, if you have handwriting, firearms, fingerprints, footwear, those are all comparisons. And this is a classification issue, that you are looking at evidence and trying to assign a classification to it. And so I tried to make these as comparable as I could in the way we did analyses, but it's something where I'm loath to try to do comparisons of these with the other disciplines. And so you can look at, certainly with the fingerprints, you can look at how things compare, but I think they're so different. I don't want to make that statement. Paul or Kev, do you want to take the next one?
Yeah, this is Paul. I'll take this one. I think the most accurate answer for that question will be time will tell. relative to how the study is going to impact us in the actual BPA evidence and court systems today. Prior research that we did with Labor and Taylor relative to similar data like this didn't really come back on us hard in the court systems. But clearly, if you take a look at our recommendations from this particular study, we have pointed out several areas to which we can shore things up relative to the semantic issues, relative to methodological issues and so forth. So we kind of have some marching orders from my perspective on where we need to go to tighten the discipline to move it forward. We obviously needed a study like this so we could actually come up with some framework on where we needed to go for the future.
Let's see, the next one, were there particular patterns that tended to be erroneously reported or indeterminate? That one, I can just say clearly, it's really complicated. And I think that's one where go into the paper. For example, there are a lot of ones where there are semantic issues, like, let's see, a drip pattern versus a splash. There was a whole lot of people would exclude one and include the other, or vice versa. And it's something where it's clear that there were certain combinations of patterns where there was not consensus on how to delineate them. And so for that answer, though, let me point you to the paper because it's complicated. The next one, do you have thoughts about how to create samples that mimic operational casework, gunshot wounds, blunt force trauma, etc.? Oh, I'll point, let me give this one to Paul because he's done a lot of training over the years.
Well, I think the key word there is mimic. We can never completely reproduce operational casework. And when we're mimicking things relative to a training mechanism, we're trying to apply certain amounts of force under certain quantities of blood and various mechanisms to create various features or characteristics which may be accountable for within operational casework. There's no real way to mimic someone's head being shot in a laboratory setting. There's been a lot of work in that particular location, but trying to mimic it or do a direct comparable is excessively difficult. Obviously, transfers of drip stains and all that stuff much easier to replicate. But when you're looking at blunt force trauma, stabbing, and gunshot wounds, very difficult. And at most, we can mimic certain features that we see within bloodstain patterns from operational casework into a laboratory setting.
I can machine gun some of them. Is the first one, how is it assessed to actual casework? I think Kevin and Paul are as experienced as anyone in the community, and so designed the test so to mimic as close to casework as they could, but limit it to this because we were concerned about a lot of things that would have a lot of biasing information on the side. Response, that's still an open question. There was a similar study. This is the first black box study. Paul Kish was involved in a smaller study several years ago. The results are very consistent. Certifying examiners, IAI certifies, and does IABPA certify as well?
No, not to my knowledge.
Terminology, the mechanism-based and observation-based terminology, it's complicated, and so the methodology is, and basically that's, look at the paper. Accredited labs versus non-accredited labs, there was not a significant response. Again, we did not find notable responses in associations. The specific pattern types we addressed. What additional information does not interject contextual bias? That's a subtle question, and it's complicated. And that's one of the reasons why we were very limited in what we provided. That what is biasing versus what is necessary information is something or other the discipline is really working on. I don't remember if we got feedback on, some people wanted additional case specific information. However, some people wanted, it's clear that some people wanted to know the answer, and then they would look at the images and see if the images supported the answer. Additional research, we go into that at length in the publication, and raise concerns about that. I raise concerns about the rate of reproducibility. What are you comparing them with? What are acceptable rates? There is not a God-given answer on what acceptable rates of reproducibility. However, when you have experts who testify in court who contradict each other at rates like this, that would be a concern. And so what an acceptable rate is different. We're not in that business. So
I want to thank you, Austin, Paul, and Kevin, for your time, for your expertise, for sharing your research. I encourage you all to look into the publication. It is posted on our website, forensicstats.org, so that you can access it there.
Yeah, if you just Bloodstain at Noblis.org, and that will give you all the links that, because there's a lot in appendices, supplemental data, and that sort of thing. So
excellent. I'm happy to link to that on our website as well. Thank you all for joining us. We hope you have a great day.